All right, guys, going to go over an Atwood machine problem on an inclined plane, just to make sure you know it. This is an important little concept for you guys to understand, so make sure you're paying attention to it. All right, so you ask yourself what it's a battle between. So let's assume for right now that the 3m mass goes down and the 2m mass goes up. So what's going to be that battle? So you have the force gravity acting on that 3m mass, which is winning the battle this way. Now, what force or forces is saying on this block, which is going up the incline, what forces say, no, I don't want to go up the incline? What forces are going to try and stop it from going up the incline? All right, so you're thinking about that for a second. You would say, all right, well, I know force gravity parallel. That definitely is always pulling down the incline. All right. The next thing to consider would be if there's friction. And if there is friction and the block's going up the incline, then that force friction would be pulling down the incline like that. All right. Now, I just made up random numbers with the 3m and the 2m just to get a feel for what it would be like. All right. As I now go to write the equation for it, and I don't care what I'm solving for yet, I go and write the equation with this one winning the battle. So it's going to be the force gravity on 3 minus the force gravity parallel acting right there minus the force friction right there, right? And that's going to equal ma. Okay, now I'm going to plug some stuff in so we can see how it's going to work plugging in. This force gravity is going to end up being 3 mg. Force gravity parallel is going to be my 2m, so 2mg sine theta. And remember, you just should have memorized that force gravity parallel is mg sine theta, minus my force friction, which is going to be mu times 2mg cosine theta. And then that's going to equal my total mass. Okay, so be careful there. It's not just the 2, it's not the 3, it's both of them. So that's going to be 2 plus 3 is 5 ma. Sorry, I'm running out of room over there. All right. Now, from this point, there's some stuff I would point out. There's a chance that I could say, for example, how much does this mass have to be to make it just barely accelerate? Or what does the coefficient of friction have to be so that it doesn't move? In that case, you would plug in 0 for acceleration. That would be gone. All right? In the problem that I wrote out right here with the acceleration, that would assume that it is accelerating up like that. All right? And in this case right here, for example, I point out that you could cancel out these masses. Okay, and then if it was a derivation, you would derive for whatever you wanted to here. It could be mu, it could be that acceleration, it could even be theta, for example. Okay, you could derive for anything like that. But that's the kind of start to kind of giddy up on that problem right there. Very important concept.